quantum mechanics problem, CSIR UGC net, December 2011. The question is the wave function of a particle at time t is equal to 0 is given by psi of 0 is equal to 1 by square root of 2 ket u1 plus ket u2, where ket u1 and u2 are the normalized eigenstates with energy eigenvalues E1 and E2 respectively, where E2 is greater than E1. Then the shortest time after which psi of t will become orthogonal to psi of 0. So this is what we have to calculate. So let us solve this problem. Solution. The solution to this problem is, so now what is given? Psi at time t is equal to 0, initial time. This is given as 1 by square root of 2 ket u1 plus ket u2. So this is what they have given. Now what we have to do is we have to calculate the psi at later time t. So this is given. Okay. So what we have to do then? So let us calculate when the psi evolves in t. So evolution in time, the psi at later time t. Okay, time evolution. Now what will happen here? It will become square root of t, 1 by square root of t. This becomes e power minus I E1 t by h bar psi 1 plus e power minus E2 t by h bar u2. Okay, we know that in the time evolution of this is nothing but this is psi at time t is equal to 0 e power minus I by h bar, okay, ht, that gives you psi at later time. Okay, so since we know this, once if we substitute e power minus I by h bar ht, when ht acts on this u1, since this is in a normalized eigenstate with an eigenvalue e1, so you will get it as e power minus I e1 t by h bar, and for u2 e power minus I e2 t by h bar. So this is what you will get. So that psi, that is a wave function at later time t, this is the answer. Now what is given next? So it is given that we have to determine the shortest time t. This t is, so for which this psi of t becomes orthogonal to psi of 0. So that means psi of t is orthogonal to psi of 0 for the time t is equal to t naught, the minimum time. Okay, so this means these two wave functions are orthogonal to each other at some time t is equal to t naught. We have to calculate the t naught, shortest time. Now how to determine this? Already we know psi of t and psi of 0. Take the inner product. Now let us write down this. See, 1 by root 2, this is also 1 by root 2. Therefore when I take product I will get root 1 by 2. So I have to write this in terms of bra vector. Therefore this will become ket u1 e power complex conjugate of minus I becomes plus I e1 t by h bar, and similarly u2 e power I e2 by h bar. Okay, so this is u1 plus u2. I have written 1 by root 2 into 1 by root 2 is 2, 1 by 2, therefore this is 0, right? So at time t is equal to t naught. So hereafter I will put for t, I will put t naught and then multiply these two. So there are two terms here, there are two terms here, so you will get 4 terms. So 1 by 2, so I will open a bracket, u1 with u1, since this is a number, so I will write down here e power I e1 t by h bar. Okay, now what is the next term? So this with second term, so this is u1 with u2, okay, e power ie1 t by h bar plus this term with the first term u2 u1 e power I e2 by h bar, okay, finally u2 with u2, okay, e power this term e power I e2 t by h bar. So hereafter I will put t bar t as t naught, okay, so will t naught and this will be equal to 0. Since it is given that they are normalized eigenstate, so therefore this is going to become 1. So this is equal to 1 and this is going to be 1, but this is 0, so this is 0, so which means 1 by 2 of e power I e1 t naught by h bar, okay, plus e power I e2 t naught by h bar, that is equal to 0. So this is what you will get. I think yeah, this is correct. Okay. Now what we have to do? We have to calculate T naught. So let us take E1 outside. So this first term outside, e power I E1 T naught by h bar outside. Okay. So we have to find out the difference E2 minus E1, right? So let's see the answer. So we have to take, and also given that E2 is greater than E1. So this means, so let us calculate, let us take e power I e1 t naught by h bar, 1 by 2 is already there. So 1 plus e power I e2 t by h bar minus I e1 t naught by h bar, that is equal to 0. So this is what you will get. Since this is a number, okay, non-zero number, and this is also non-zero, okay, so this becomes 0 because the right hand side it is 0 only if the bracket term goes to 0. So writing the bracket term to be 0, so what you will get is 1 will become 1 plus e power I by h bar t naught e2 minus e1, that is equal to 0, which can be written as e power I by h bar t naught e2 minus e1, that is equal to minus 1, which can be written as e power I pi. Okay, now what happens? So base is same, so you can equate the power I by h bar t naught e2 minus e1, that is equal to I pi. So I gets cancelled, so t naught is equal to e2 minus e1, sorry, so this becomes pi. So this term h bar I will take numerator, so e2 minus e1, so this is what you will get. Okay, for this is the minimum time. So the answer for this problem is pi h bar by e2 minus e1, pi h bar by e2. So answer for this problem is second one. So there is another problem asked in JEST 2016. It's a similar problem. So let us solve this problem. A spin-off particle in a uniform external magnetic field has energy eigenstate 1 and 2. So the system is prepared in ket state. It's a superposition of these two states, eigenstate. So ket 1 and ket 2 by root 2 at time t is equal to 0. Therefore, the system is initially at this state. Okay. So it evolves to the state described by the ket state, the difference between them, that is ket 1 minus ket 2 by uh, ket 1 by ket 2 by root 2. So it has to be root 2, okay, in time t. So we have to calculate the minimum energy difference between the two levels. So, so solution to this problem is, so what is given? System at initial time t is equal to 0 is equal to, it's a superposition of these two states, that is ket 1 ket 2 divided by root 2, and it is when it is at time t, okay, later time t, it is in the superposition state, that is 1 minus 2 ket 1 minus ket 2 divided by root 2. Now we have to find out the minimum energy difference between the two levels. How to solve this problem? The same method. So we know that when this is the initial state, and the time evolution, okay, so that is at time t, so this becomes 1 by root 2, you keep as it is. So what is the time evolution of this? This is e power minus I e1 t by h bar ket psi 1 ket 1, and this will become e power minus e2 t by h bar 2. Why I put this? Because they are the eigenstates. Okay, so therefore you will get, when a Hamiltonian e power minus I h t by h bar acts on the state, I will get energy as E1. For the second state, I will get energy as E2. It is given here. They are the eigenstates. Okay, now what we have to do? So we have to let us now take this out, 1 by root 2. Okay, so let us take e power minus I e1 t by h bar out. So what you will get is 1 plus this term, this first term can be written as minus I e power minus I e2 minus e1 by h bar t get 2. So we can write like this. Now what is required? So at time t is equal to this capital T, so at t is equal to capital T, so what is going to happen? The state becomes this one. So this term, okay, get 1 minus, I should get this one. Okay, so therefore what I required is this term has to become minus 1. So this term must become minus 1. Okay, so this term has to become minus 1. So therefore e power I minus I, okay, so e2 minus e1, e2 minus e1 by h bar, when t is equal to capital T, okay, this has to become minus 1. Therefore minus 1 means what? I can write it as e power I pi. I can write it as e power I pi. I can also choose it as e power minus I pi. That doesn't matter. So if I take this as a e power minus I pi, I will get same minus 1. So equating the powers, so you will get it as I minus I e2 minus e1 by h bar into t, that is equal to minus I pi. So I and minus also gets cancelled. So e2 minus e1 will now become pi h bar by t. Now h bar is nothing but what? H by 2 pi. So this becomes pi h by 2 pi. So this becomes h by 2 pi by t. Pi pi gets cancelled. Therefore h by 2t is the answer. So answer for this problem is C.
Thank you for watching the video. If you liked the video, please press the like button. If you are interested in receiving information about new videos that are posted, click the subscribe button. If you have any comments or questions about the content discussed in the video, Please leave them in the comments section below.